Plastic pollution is one of the most serious environmental problems facing the world today. Every year, millions of tons of plastic waste are generated from households, industries, and commercial activities. Much of this plastic ends up in landfills, rivers, oceans, and open dumping sites, where it can remain for hundreds of years without decomposing. At the same time, the construction industry requires enormous quantities of materials for roads, pavements, walkways, and buildings. One innovative solution that addresses both of these challenges is the production of plastic sand tiles. These tiles are manufactured by combining waste plastic with sand to create a strong composite material that can be used in a variety of construction and landscaping applications. By converting discarded plastic into useful building products, plastic sand tile manufacturing helps reduce environmental pollution while creating durable and cost-effective construction materials. The basic principle behind plastic sand tiles is relatively simple. Plastic acts as a binding material that holds sand particles together after it has been melted and allowed to cool. Unlike conventional concrete tiles, which depend on cement and water for binding, plastic, sand tiles, rely on molten plastic to create a solid structure. The resulting product is often resistant to water, durable under normal use conditions, and capable of withstanding considerable loads depending on its composition and manufacturing process. Because these tiles make use of waste materials that might otherwise be discarded, they are often considered an environmentally friendly alternative to some traditional paving and flooring products. The manufacturing process begins with the collection of suitable waste plastic. Plastic waste can be obtained from households, recycling centers, businesses, markets, and industrial facilities. Common sources include plastic bags, packaging films, detergent bottles, milk containers, food packaging, bottle caps, and various other discarded plastic products. However, not all plastics are suitable for this process. The most commonly used plastics are low-density polyethylene, LDPE, high-density polyethylene, HDPE, and polypropylene. These plastics can be melted and reshaped repeatedly without undergoing major chemical changes. Certain plastics, such as polyvinyl chloride, PVC, are generally avoided because they can release hazardous fumes when heated and may negatively affect the quality and safety of the final product. Once the plastic waste has been collected, it must be sorted carefully. Sorting is an important stage because different types of plastic have different melting temperatures and physical properties. Mixing incompatible plastics can result in inconsistent melting behavior, poor bonding, and reduced tile quality. During sorting, workers separate plastics according to their type and remove contaminants such as metal pieces, glass fragments, paper labels, rubber materials, and other foreign objects. Proper sorting contributes significantly to the consistency and performance of the finished tiles. After sorting, the plastic must be cleaned thoroughly. Waste plastic often contains dirt, food residues, oils, adhesives, and other contaminants that can interfere with the manufacturing process. The cleaning stage typically involves washing the plastic with water and detergent to remove unwanted substances. After washing, the plastic is rinsed and allowed to dry completely. Moisture is undesirable because it can create steam during heating, leading to bubbles, voids, and defects in the finished product. Thorough drying ensures smoother processing and stronger bonding between the plastic and sand. The cleaned plastic is then shredded into smaller pieces. Shredding increases the surface area of the plastic and allows it to melt more quickly and uniformly. Depending on the equipment being used, the shredded plastic may range from a few millimeters to several centimeters in size. Uniform particle size helps achieve consistent melting and mixing, which ultimately improves the quality of the finished tiles. The shredded material is typically stored in dry conditions until it is ready for processing. While the plastic is being prepared, attention is also given to the sand that will be used in the mixture. Sand serves as the primary filler material and contributes significantly to the strength and rigidity of the tiles. The sand should be clean, dry, and free from organic matter, clay, and debris. Screening is often performed to remove oversized particles and ensure a consistent grain size. In some cases, the sand is washed and dried before use. Dry sand is essential because moisture can create steam when mixed with molten plastic, leading to defects and weakened bonding within the composite material. Once both materials have been prepared, the appropriate mixing ratio must be determined. The ratio of plastic to sand can vary depending on the desired properties of the finished tile. Common formulations range from 1 part plastic to 2, 3, or 4 parts sand by weight. Lower sand content generally increases flexibility, while higher sand content often improves stiffness and compressive strength. Manufacturers frequently conduct testing to determine the optimal ratio for specific applications and local material characteristics. The next stage involves melting the shredded plastic. The plastic is placed in a heating vessel, furnace, or specialized mixing unit and heated until it reaches a molten state. The required temperature depends on the type of plastic being processed. Careful temperature control is extremely important because overheating can cause degradation of the plastic, resulting in reduced strength, discoloration, unpleasant odors, and the release of fumes. The goal is to achieve a smooth, uniform molten mass that can effectively coat and bind the sand particles. After the plastic has melted, the prepared sand is gradually added to the molten plastic, while continuous mixing is maintained. Thorough mixing is necessary to ensure that every sand particle becomes coated with plastic and that the material remains homogeneous throughout. Uneven mixing can create weak zones within the tiles and reduce overall product quality. As the mixing process continues, the material develops a thick, uniform consistency suitable for molding. The molds used for tile production are prepared before the mixture is transferred. Molds may be manufactured from steel, aluminum, or other durable materials capable of withstanding repeated heating and cooling cycles. They can be designed to produce a wide variety of tile shapes and patterns, including square tiles, rectangular paving blocks, decorative floor tiles, and interlocking pavement units. A release agent is often applied to the mold surfaces to prevent sticking and facilitate easy removal of the finished products. The hot plastic sand mixture is then placed into the molds. Care must be taken to distribute the material evenly and fill all corners completely. Uniform filling ensures consistent tile dimensions and reduces the likelihood of internal defects. After filling, the material is compacted using either manual methods or hydraulic presses. Compression is an important step because it increases density, removes trapped air, improves bonding, and enhances the strength of the final product. Well-compacted tiles typically exhibit better durability and surface quality than tiles that have not been adequately pressed. Following compression, the tiles are allowed to cool and solidify. During cooling, the molten plastic hardens and firmly binds the sand particles together, creating a rigid composite structure. Cooling may occur naturally in ambient air or through controlled cooling systems, depending on production scale and equipment availability. Gradual cooling is generally preferred because it reduces the risk of internal stresses, warping, and cracking. Once the tiles have cooled sufficiently, they are removed from the molds and inspected for defects such as cracks, incomplete filling, surface irregularities, or dimensional inaccuracies. Quality control plays a crucial role in ensuring that the tiles meet performance requirements. Various tests may be conducted to evaluate properties such as compressive strength, impact resistance, abrasion resistance, water absorption, and dimensional stability. These tests help manufacturers identify potential weaknesses and maintain consistent product standards. Defective tiles can often be recycled by crushing and remelting them for future production batches, further contributing to waste reduction and resource efficiency. Plastic sand tiles have numerous practical applications. They are commonly used for pedestrian walkways, garden paths, courtyards, outdoor flooring, parking areas, and public recreational spaces. Their resistance to water makes them particularly useful in environments where moisture exposure is common. In addition, their durability and relatively low maintenance requirements make them attractive alternatives to certain conventional paving materials. Depending on the manufacturing process and formulation, plastic sand tiles may also offer resistance to cracking and weather-related deterioration. The environmental benefits of plastic sand tile production are substantial. By utilizing waste plastic as a raw material, the process helps divert large quantities of plastic from landfills and natural ecosystems. It also reduces demand for traditional construction materials and can contribute to a circular economy in which waste materials are transformed into valuable products. Furthermore, because the process does not rely heavily on cement, it may help reduce greenhouse gas emissions associated with cement manufacturing. These advantages make plastic sand tiles an appealing option for communities seeking sustainable waste management and construction solutions.